So in this video I'm going to describe what I did for my senior project, my senior year in high school. I designed and built a plate reverb, which is an analog piece of music equipment used in the studios of the 60s and 70s and late 50s. It's based around the reflective qualities of steel, of very thin steel plate, and that's where you get the plate reverb name. That's where the name plate reverb comes from. So behind me is the mechanism that I built. The plate, this very thin steel is tensioned inside a welded metal frame that I built. This mechanism here is the damper plate that can be moved closer or further away from the plate to change the tonal qualities and the length of the reverberation. So what happens is you send audio signal to the speaker, and just like what a speaker is supposed to do, it turns the electrical signal that you have that represents mechanical sound, the mechanical movement of the speaker, which creates sound, but instead of pushing it out into the air, it pushes it onto the plate, and you get the sound wave that you would normally get coming out of a speaker going onto the plate. And what happens is the waves bounce along the side of the plate. They hit the edge of the tension side, and they bounce back. That is the how the reverb is actually created, because reverb is I'm a sound source, right? Because I'm speaking, and so if I clap my hands, we're actually in a big room right now. The sound has to the sound, which is just air molecules compressed and then decompressed and compressed and decompressed, and you can model that in a sine wave function. Is how it's normally done. That has to reach the walls, or where I'm standing, and then it has to come back to my ear. That is the reverberated quality. So I'm hearing a delay in what I'm speaking. So you hear the original, my voice, because it's right, my ears are right next to my mouth, but then I'm hearing a few seconds later the sound that's bounced off the walls and back to my ear. So just like the sound leaves my mouth, bounces off the walls, and comes back to my ear, the sound travels from the loudspeaker to the edge of the plate and bounces back. While that's happening, because you don't send one wave and then wait for the wave to go back. What you do is you send, a continuous source of sound, like piano being played or someone singing. And so, as those waves travel across, they bounce, but then as they're coming back, more waves are coming, right? So this creates these wave interference on the plate, and that further enhances the kind of wishy-washy reverb sound you want. Okay, so you've got the sound on the plate, but that's of no use if you want to use it in the studio, recording studio. So what these pickups do, like I said before, is convert that new waveform that you have, the multiple layered and new reverby sound, and take that audio signal out back into the mixing board or wherever your audio signal path goes. For this project, I had to. There's a lot of steps. Planning, I had to, I found plans online originally that I figured I could use at least a little bit, and I started to follow them exactly, but that only lasted about like an hour or something, because it turns out that in order to, especially when you find plans online, you really have to, you have to modify them almost every time. And so for this one, I had to do a lot of modifications in terms of how the frame was built, in terms of what kind of steel I used, how the corner reinforcements of the steel was. So I found someone who would help me, who would teach me how to weld, and learned how to weld, and then built the frame. The next step, I built the required electronic circuits. There's 4 of them. Technically, there's 4. There's one circuit that adds voltage to the sound that goes to the loudspeaker. There's 2 that take the output of the transducers and convert it into an applicable signal for a mixing board or another recording process. And the last is a power supply that converts 120 volt wall socket alternating current to 30 volts direct current. So those are all housed in these metal fixtures here, which serves as the hub for how you would use it. There's wooden slats that fit in here. Oh, and this doorknob here is the the grip for the damper mechanism. So if you turn it, it brings the damper further and out from the surface of the plate, and that's the tonal qualities, reverberating time. Let's see. The frame was built last, and a lot of people think that the frame is merely for looks, but it turns out that it's actually very important for the plate to be isolated, because it is a tension piece of steel. If I'm using it in the studio and someone's standing next to it and talking like this, you can actually hear someone's voice through it because the air is pushing against it. So the wood that fits in here in the frame itself provides extra isolation. So this is a demonstration of how the sound is transferred to the plate, but not back, because that system is isolated to the headphones now. So if you might be able to hear it. If I tap on this microphone, you can hear that the sound of the tapping reverberating across the plate. Or if I talk, you can hear it. Sounds like I'm standing. Well, combined with the room I'm standing in, kind of makes it a little hard to truly get the sound I want. But if I have, you can hear me speaking, and you can hear that it drags the sound out a lot. So what you do in the studio is you have your signal. You have someone sing or record or play piano or whatever, and you record that, and then you duplicate that track, and you send that duplicated track to the plate, and then you take those outputs and you have another track. So you end up having three channels. You have, because a duplicated track is not one that you really mess with. It's just duplicated in terms that it has to become its own output. It's hard to explain. But it's duplicated, but it's not represented on the board. So you have your original track, which I have here as 1. So the microphone goes in here, goes to the plate, and then it comes back as channel 8. So plate reverbs were the answer to how artificial reverb was going to be created before the digital ones became any good or even existed. As soon as the digital world and digital signal processing got good enough to create reverb, people were like, why do I need a 350-pound steel plate? I could just have a computer or like a little outward box and I can get a lot more effects. You know what I mean? But the cool part about this is that there's no reverb in the entire world that'll sound exactly like that one. This is completely different and no one can recreate it. You know, I think that's the cool part about it. And also it gets you a lot of different effects that you couldn't achieve with a digital reverb. Like I could bypass the whole like sending audio there, and I could just put my guitar amp next to it and play guitar through it and just take the returns, and I get this weird guitar effect that, you know, I wouldn't be able to do without with a digital reverb.